In this video, I'll be solving A-Level Physics February-March 2022 Paper 1. In case you haven't subscribed to my channel yet, then subscribe to my channel for more videos related to A-Level and O-Level. Let's begin. Question number 1. What could not be a measurement of a physical quantity? Now, a physical quantity has a magnitude and a unit. It always has these two things. Let's check all these options. Option A, 10 Kelvin. Now 10 is the numerical magnitude, Kelvin is the unit. So it is a physical quantity, is not the answer. B, 11 joules per Newton meter. Now joules is the SI unit for energy or work done. And what's the formula for work done? Work done is force multiplied by distance moved in the direction of force. The SI unit for force is Newton and the SI unit for distance is meter. So this is Newton meter multiplied by Newton meter per Newton meter, or Newton meter multiplied by n raised to the power minus 1 m raised to the power minus 1. So Newton meter will cancel n raised to the power minus 1 m raised to the power minus 1 and only 11 will remain. So it has, option B has a numerical magnitude only, it does not have a unit. So B is not a physical quantity. B can be our answer. Let's check the other options as well. Option C, 17 pascals per meter cube, 17 pascals meter cube per Newton. Okay, so what is Pascal? Pascal is the SI unit for pressure, and pressure is force upon area. Now force, the SI unit for force is Newton, the SI unit for area is meter squared. But since it is force upon area, so it will be Newton per meter square or Nm minus 2. Now this thing is multiplied to m cube and then n raised to the power minus 1. So this will cancel that, and m cube multiplied by m raised to the power minus 2 will be equal to meter. So the option C is 17 meter. Now m meter is the unit and 17 is the numerical magnitude. So C is also a physical quantity. C can be the answer. Let's exclude C. D, 25 terameter. Now tera is a prefix which stands for multiplied by 10 raised to the power 12. So it has a numerical magnitude 25 and a unit. D can be the answer. We have only B as the choice, so B is the correct option because there is no unit, it only has a numerical magnitude. B is the answer. Question number 2. A computer memory stick is labeled as having a storage capacity of 128 GB. The letter B stands for byte, which is a unit. What is the equivalent storage capacity? Now G is a prefix. G stands for giga. And 1 gigabyte, 1 giga, the prefix giga means 10 raised to the power 9. So we have 128 multiplied by 10 raised to the power 9 bytes. Now if you simply put this in a scientific calculator, you will get the answer 1.28 multiplied by 10 raised to the power 11. Or if you move 2 decimal places to the left, you can say that it will be 10 raised to the power 11. 1.28 raised to the multiplied by 10 raised to the power 11. So B is the answer. B is the correct option. Question number 3. A man of mass 75.2 kg uses a set of weighing scales to measure his mass 3 times. He obtains the following readings. Reading 1 80.2 kg, reading 2 80.1 kg and reading 3 is 80.2 kg, which a statement describes the precision and accuracy of the weighing scales. Now what's the difference between these two terms? What do these mean? Precision basically means that these readings must be close to each other. What I'm trying to say is that precision means that the individual readings must be close to the average of those readings. These readings. So if the average, let's say the average of these readings is 80.15 or 80.16. Now these readings must be close to each other. And accuracy means that the average deviation of the individual readings from the true value, which is 75.2 kg, must be small. So the average deviation of these individual readings from this must be small. Now Are these readings accurate? No, they are not accurate to 0.1 kg plus minus 0.1 kg because the average deviation is not small. So let's exclude A and C. Now we have B and D remaining. Are they precise? Yes, they are precise because we have 80.2, 80.1 and 80.2 kg, and these readings are close to each other, so they are precise. So B can be the answer. They are precise but not accurate. D is the answer. So option D. Question number 4b. Which statement about scalar and vector quantities is correct? A scalar quantity has magnitude only and a vector quantity has both magnitude and direction. So A scalar quantity has direction but not magnitude? No. A scalar quantity has magnitude but not direction? Yes. A vector quantity has direction but not magnitude? No, it has both. A vector quantity has magnitude but not direction? No, it has both. So B is the answer. Question number 5. How can the acceleration of an object be determined? From the area under a displacement time graph. Okay, the area under a displacement time graph cannot be used to determine the acceleration. The area under a velocity time graph. The area under a velocity time graph represents the displacement. B is not the answer. C. From the gradient of a displacement time graph. The gradient of a displacement time graph represents the velocity of the object. D. From the gradient of a velocity time graph. Now that's the correct answer because the gradient of a velocity time graph is the acceleration of an object. C. In the velocity time graph, we have velocity on the y-axis and time on the x-axis. Now what is gradient? Gradient is y values upon x values or rise over run. Now if you write velocity on top and time velocity as numerator and time as denominator, so this will be the gradient, and the formula for acceleration is also this. The formula for acceleration is change in velocity upon change in time or time taken. So D is the correct answer. Question number 6. A sprinter takes a time of 11 seconds to run a 100-meter race. She first accelerates uniformly from rest, reaching a speed of 10 meters per second. She then runs at a constant speed of 10 meters per second until the finish line. What is the uniform acceleration of the sprinter for the first part of the race? If we draw the velocity time graph of this sprinter, it will be something like this. Velocity on the y-axis, time on the x-axis. Okay. Now, she accelerates uniformly and then she moves at a constant speed, which is 10 meters per second. The total time she takes is 11 seconds. Now we have to find the uniform acceleration or the gradient of this line. We have to find the uniform acceleration, initial acceleration. Okay. Now, the formula to calculate acceleration is change in velocity upon change in time or change in velocity upon time taken. We can also write that the change in time or time taken can be calculated using change in velocity divided by acceleration. Okay. Now the change in velocity is 10 meters per second because it increases from 0 to 10 and we are given the accelerations. So we can use this to calculate the initial time she took for uniform acceleration. Let's do this. In option A, 0.5 meter per second squared is the initial acceleration. 10 divided by 0.5 is equal to 20. This is trying to say, option 1 is trying to say that 20 seconds is the initial, she took 20 seconds for the initial acceleration. Now obviously option B can be the answer because 11 seconds is the total duration of the journey. If she took 20 seconds for the initial acceleration, then obviously she can't complete the entire journey in 11 seconds. So A is not the answer. Let's check option B. Option B says 0.91 meter per second squared. Now 10 divided by 0.91 is equal to 10.98 seconds, and this means that she took 10.98 seconds for this part. 10.98, and if you subtract 10.98 from 11, the remaining thing will be 0.02 seconds. So option B says that she took 10.98 seconds for initial uniform acceleration and then 0.02 seconds for the remaining journey for this part. Now obviously we know that this can be the answer, but let's prove this mathematically that this is not the answer. Now there is an equation v square is equal to u square plus 2as. V square is the final velocity, u square is the initial, v is the final velocity, u is the initial velocity, a is the acceleration, s is the displacement. Now final velocity is 10, so 10 squared, u is the initial velocity is 0. Then we have 2 multiplied by a, acceleration is 0.91, and we have to find out the displacement. So 10 squared divided by 2 divided by 0.91, we get the displacement is 54.94 meter. Now 54.94 meter for this shaded part. Okay. If she travels 54.94 meter in 10.98 seconds, this means that she must cover the remaining out of 100 minus 54.94 meter in 0.02 seconds, because the remaining time she has is 0.02 seconds. But her speed is 10 meter per second and distance is speed multiplied by time. Now if you multiply 0.02 by 10, you get 0.2 meter as the answer, and 0.2 plus 54.94 is somewhere 55 point something, which is obviously not equal to 100. It is less than 100, so B is not the answer. Let's check option number C. Okay, so option number C, 1.7. Now 10 divided by 1.7 is 5.882 seconds. Now 5.882 seconds for this initial part, 5.882 for this part, and the remaining part is 11 minus 5.882, which means the remaining part is 5.117 seconds. 5.117 seconds. Okay. Now let's check. V square is equal to u square plus 2as. 10 square is equal to 2 multiplied by acceleration is 1.7 multiplied by displacement. Okay. So the displacement is 29.4 meter. The answer is 29.4. So the displacement initial during uniform acceleration is 29.4 meter, and her remaining time is 5.117 seconds. Okay, so the remaining time is 5.11 seconds and her speed is 10 meter per second. If you multiply 5.117 by 10, the answer you get is 51.17 meter. Now if you add 51.17 and 29.4, the answer will be 80.58 meter, and 80.58 is obviously less than 100, so C can't be the answer. Now we have only one option D remaining. Let's prove mathematically. Let's check if D is the answer. Okay, so 5 meter per second squared, 10 meter per second is the change in velocity. This is the acceleration. The time she takes is 2 seconds. 2 seconds for this part, which means 2 seconds for this part, and 11 minus 2, so 9 seconds for the remaining part. Okay. Now V square is equal to U square plus 2as, and V squared is 10 squared, and then we have 2 multiplied by 5 multiplied by S. Now the displacement S is 10 meter, and the remaining time is 9 seconds, and her speed during 9 seconds is 10, so 9 multiplied by 10 is 90 meter, and if you add 90 meter and 10 meter, the answer you get is 100 meter. So yes, D is the answer because she travels we can mathematically prove that D is the answer because she takes 2 seconds to travel 10 meter during her uniform acceleration of 5 meter per second squared until she reaches a velocity of 10 meter per second, and then she travels constantly uniformly at a constant velocity of 10 meter per second for 9 seconds, during which the distance she covers is 90 meters. So 90 plus 10 is equal to 100. Now let's move to question number 7. Okay, so in question number 7, A single horizontal force F is applied to a block which is in contact with a separate block Y as shown. The blocks remain in contact as they accelerate along a horizontal frictionless floor. Along a horizontal frictionless surface, air resistance is negligible. X has a greater mass than Y. Which statement is correct? Now, the formula for force, the formula for force is mass times acceleration, and this force F is acting over these two blocks, block X and block Y. So this mass is mass of X, which I am writing as mx, plus mass of Y, my. Okay, so the formula is this. Now the acceleration is force over mx plus my. Acceleration is force divided by the combined mass of these two blocks. Now let's check the options. Option A says the acceleration of x is equal to force divided by the mass of x. No. The acceleration of x is equal to force divided by the mass of block x and the mass of block y. A is not the answer. B. The force that x exerts on y is equal to f. No. The force that x exerts on y is equal to this acceleration, which is F upon mx plus my. This acceleration multiplied by the mass of x, which is mx. And obviously this thing will be less than the force because the denominator mx plus my is greater than mx. So B is not the answer. Option C. The force that x exerts on y is less than F. Yes. C, because this force is acting on these two bodies. So obviously this force, the force that one object exerts on another cannot be equal to the force F. It will obviously be less. So option C is the answer, but let's check option D as well. The force that x exerts on y is less than the force that y exerts on x. This doesn't make sense because Newton's third law says that action and reaction forces must be equal. Okay, so D is not the answer. C is the correct answer. Option C is correct. Question number 8. A car of mass 750 kg has a horizontal driving force of 2 kN acting on it. It has a forward horizontal acceleration of 2 meter per second squared. What is the resistive force acting horizontally? C. The formula for force is mass times acceleration. The mass is 750 kg. The acceleration is 2 meter per second. Okay, so 750 multiplied by 2. The answer we get is 1500 Newton. The driving force is 2 kilonewton and kilo means 10 raised to the power 3, 2000 Newton. Now, the car is applying the car has a forward force of 2000 Newton. But the resultant force is 1500 Newton. Now, this means that the car is applying 2004 Newton. The driving force is 2000 Newton. But only 1500 Newton is acting. Only 1500 Newton is the resultant force. Which means that 2000 minus 1500 Newton is 500 Newton. This 500 Newton force is not being used, which means that this is the resistive force. Okay. Now, since our options are all in kilonewtons, we have to convert our answer in kilonewtons. Now, 1 kilonewton is equal to 1 Newton raised to the multiplied by 10 raised to the power 3. So we can divide 500 by 10 raised to the power 3 and the answer we get is 0.5 kilonewton and answer is option A. Question number 9. An object falls freely from rest in a vacuum. The graph shows the variation with time t of the velocity v of the object. Which graph using the same scales represents the object falling in air? Now, in a vacuum, only weight acts on the object. So it has constant acceleration, the increase is uniform, and we have a velocity time graph with a constant gradient. But in air resistance is also acting on the object. So we have two forces, air resistance and weight. Now, the thing is that air resistance will keep on increasing until air resistance is equal to weight. And at that point, these two forces are equal. So when these two forces are balanced, the resultant force is 0 and acceleration is 0. So the acceleration keeps on decreasing until it is equal to 0. And since the gradient of a velocity time graph is acceleration, the gradient will keep on decreasing. So the velocity time graph will look something like this. First, the velocity will increase, but then it starts to decrease because the acceleration will decrease. Okay, now let's check the options. Option A suggests that there is a constant gradient, which means there is constant acceleration. A can be the answer because there is not constant acceleration. The acceleration decreases as the forces become balanced. Now option B suggests that the acceleration decreases, and option C suggests this too. We'll compare them later. Let's check option D first. In option D, the velocity is increasing and the gradient is increasing. Now since the gradient is increasing, this means that the acceleration is decreasing. First we have a graph which is almost a horizontal line, and then this horizontal line is becoming more a vertical line. And if you compare the gradient at different points, the gradient is increasing, which means the acceleration is increasing. So if the acceleration is increasing, the forces are not becoming balanced. So option D obviously can't be the answer. Now we have option B and option C remaining. Okay, they have written in bold using the same scales, which means we have to take into account the readings, or we have to compare these graphs. Okay, so see, if there's air resistance acting, obviously the velocity reached cannot be equal in option B. And in the graph where the object is in vacuum, you can easily see that the velocity both objects reach are equal. In fact, the velocity both of these objects reach are equal. But this can't happen because when there is air resistance acting, there is a resistive force. So obviously you can't reach the same velocity. So option B cannot be the answer. Now why is option C correct? Option C is correct because if there is air resistance acting, there is a resistive force, and this resistive force increases until it is equal to weight. And when this happens, we have a terminal velocity, and at that point the acceleration is 0 and forces are balanced. So the gradient decreases in both. But we also have to take into account the final velocity reached. The final velocity reached must obviously be less than the final velocity reached when that object was in vacuum, because there is a resistive force acting. So option C is the answer, because the final velocity reached is obviously less than the final velocity reached in vacuum. Okay. So question number 10. A rock of mass 2m traveling in deep space at velocity v explodes into two parts of equal mass, one of which is then stationary. What is the kinetic energy of the moving part after the explosion? Okay, so there is a rock of mass 2m. Let's say that this is the rock, its mass is 2m. It's traveling with a velocity of v. It explodes into two parts of equal mass, one of which is then stationary. Two parts of equal mass means each of the rock has a mass m. What is the kinetic energy of the moving part after the explosion? Okay, so we have the formula for kinetic energy is 1/2 multiplied by the mass multiplied by velocity squared. Okay, we have the mass m, we have to find out the velocity. Now we can use this using the the equation for momentum, law of conservation of momentum. Okay, so the initial momentum is mass into velocity multiplied by velocity. The initial mass is 2 meter and the velocity is v. And the final after explosion, there are two parts one of them is stationary, so m multiplied by 0, and we have to find the velocity of the other one, m multiplied by velocity. I'm just writing velocity. Okay, we have to find the velocity of this one. Now we have 2mv is equal to m multiplied by velocity. Now m cancels this m, the velocity is 2v. 2v is the velocity. Now we can say that 1 upon 2 multiplied by m, this mass, multiplied by 2v squared is our kinetic energy. Now 2v squared is 4v squared. Okay, so this thing is equal to 4v squared multiplied by m divided by 2. So the answer we get is 2mv squared. So option D is correct, the rest are incorrect. The answer is option D. Let's check question number 11. A horizontal metal bar PQ of length 50 cm is hinged at NP. The diagram shows the metal bar viewed from above. Two forces of 16 Newton and 5 Newton are in horizontal plane and act on end Q as shown. What is the resultant moment about P due to the two forces? Okay, now there are two forces acting on a metal bar. This point P is the pivot, and this point Q is where the two forces act. Now obviously one force is acting perpendicular to this point, which is 5 Newton. This one is easier, and the other force is acting at an angle, but we only consider the perpendicular component. In this case, the perpendicular component is the sine component, so we say that the force that acts on it is 16 sine 30. Okay, now sine 30 is 1 upon 2 and 16 sine 30 is 8. So 8 Newton is the force, the vertical component of the force because of the 16 Newton force, and 5 Newton is the other force. Okay, so we have to find out the resultant moment, and since these two are in opposite directions, so one of them is positive and one of them is negative. If we take anti-clockwise to be positive, which is this is anti-clockwise. If we take this one to be positive, so 8 will be positive and this 5 Newton will be in the clockwise direction, so this will be negative. So okay, one more thing is that this is 50 centimeter. You have to first convert it into meter, which will be 0.5 meter. Okay, now we have 8 multiplied by 0.5 minus 5 multiplied by 0.5. Now 8 multiplied by 0.5 is 4 Newton meter, and 5 multiplied by 0.5 is 2.5 Newton meter, and 2.5 subtracted from 4 is 1.5 Newton meter. So A is the answer. The rest options are incorrect. A is the correct answer. Question number 12. A cube WXZY has sides of length 2 cm and mass 24 gram. The cube rests on a meter rule of negligible mass. The geometrical center of the cube is vertically above the 70 cm mark on the scale of the rule. The cube has a non-uniform density so that its center of gravity is not at its geometrical center. The center of gravity of the cube is in the plane of the diagram. The rule rests on a pivot at the 50 cm mark. A mass of 23.4 gram is placed vertically above the 30 cm mark. The rule is horizontal and in equilibrium. What can be determined about the position of the center of gravity of the cube? Now this rule is in equilibrium and we have to determine, okay, so they are asking us what can be determined about the position of the center of gravity of the cube. Now the geometric center of the cube is at the 70 centimeter mark, but they are telling that the center of gravity is not at the geometrical center. It has non-uniform density, so it is not at the geometric center, but it is in the plane of the diagram. It is somewhere around this shape, this square which we are seeing in this diagram, but it is not at the center. and these two objects are balanced. Now this is vertically above 30 centimeter, so the distance is 20, and the mass is 23.4 gram. 20 centimeter, 23.4 gram. Since the rule is in equilibrium, we can say that the moment because of this cube is equal to the moment because of the mass. The anti-clockwise and clockwise moments are equal to one another, and we can say that the moment because of these two are equal. The turning effect are equal. We can write 23.4 multiplied by 20 is equal to 24 gram multiplied by x. Okay. Now 23.4 multiplied by 20 is equal to 468 is equal to 24 multiplied by x. X is equal to 468 divided by 24. X is equal to 19.5. Now what I did here was that 23.4 is its mass, and this mass is perpendicular to this distance. Okay, so the distance was this 20 centimeter. I multiplied them, and then I multiplied 24 with x, and I solved for x. X was 19.5. So this means that the center of mass is at 19.5, somewhere around this thing, 19.5. Okay, now 19.5 from 50, which means 50 plus 19.5. 50 plus 19.5 is 69.5. It is somewhere around 69.5. We obviously don't know where it is because the cube has a non-uniform density, but it is somewhere around this 69.5. It must be somewhere along a horizontal line that is 0.5 centimeter from the line WX. No, because it must be somewhere along a vertical line that is 0.5 centimeter from this line WY. We just found that out. Okay, so option A is incorrect. Option B, it must be somewhere along a horizontal line that is 0.5 centimeter from the line YZ. YZ can't be the option. In fact, can't be along a horizontal line. It must be along a vertical line from WY or along a vertical line from XZ. Okay, so it must be somewhere along a vertical line that is 0.5 centimeter from the line WY. This is the correct option because 69.5 meter was our answer, which means this thing. Now it must be somewhere along this vertical line that is 0.5 centimeter from the line WY. Only this option fits our answer only. Okay, and option D suggests that it must be somewhere along a vertical line that is 0.5 centimeter from the line XZ. This can't be the answer because 69.5 meter was our answer, and only option C fits that. Okay, so C is correct. Question number 13. A rigid sphere is held at rest on the seabed. When the sphere is released, it rises to the surface of the sea. The seawater has a uniform density. Which statement about the sphere from its release until it reaches the surface is correct? The sphere always moves with constant acceleration. No, it does not move with constant acceleration because obviously there may be some resistive forces acting because of water, and obviously it does not move with constant acceleration. There is weight also, upthrust and other forces, so there won't be constant acceleration. B, the sphere always moves with constant velocity. No, constant velocity means that there is constant acceleration, and since they're writing that always moves, so obviously it does not constant velocity means that there is zero acceleration. There is no acceleration acting, and in the initially there is some acceleration acting on it. There is some force acting on it which causes acceleration, so there isn't constant velocity. Option B is incorrect. C, the upthrust on the sphere always decreases. Just pause for a second. Okay, let's begin. Erasing it. Question 13. A rigid sphere is held at rest on the seabed. When the sphere is released, it rises to the surface of the sea. The seawater has a uniform density. Which statement about the sphere from its release until it reaches the surface is correct? The sphere always moves with constant acceleration. No, it does not always move with constant acceleration, because there are forces acting on it, and obviously there can't be constant acceleration always. The upthrust and the weight remains constant, but other forces are changing. The upthrust and the resistive force because of water. So A is not the answer. B is suggests that the sphere always moves with constant velocity. Constant velocity means zero acceleration, and if there is zero acceleration, this means that the resultant forces are balanced. But this is not the case. Initially, there is some acceleration because of caused by force, so it does not always move with constant velocity. Option C, the upthrust on the sphere always decreases. So upthrust is equal to F is equal to rho g v. Density multiplied by acceleration due to free fall, g multiplied by velocity, and the upthrust does not decrease. It is always constant because the seawater has a uniform density, so it does not decrease. The upthrust on the sphere is always constant. Yes, D is the correct answer. Okay. Question number 14. What is a unit for density? Okay. So what is density? Density is mass over volume. The SI unit for mass is kg. The SI unit for volume is meter cube. So density is kg m raised to the power minus 3. What is a unit for density? Now let's check all these options. A suggests that it is m raised to the power minus 3. Now Newton is force. Force means mass times acceleration. So this means the SI unit of mass multiplied by SI unit of acceleration divided by SI unit of volume upon volume. A can't be the answer. B. Gram per millimeter raised to the power minus 1. This can't be the answer. C is kg per centimeter square. This can't be the option because the SI unit for mass is correct, but this is the SI unit for this is the unit for area. This is not a unit for volume. Okay. Then in option D we have microgram per millimeter cube. Now micro is a prefix and milli is also a prefix. So this is G multiplied by 10 raised to the power minus 6. And then we have meter multiplied by 10 raised to the power minus 3. So the prefix micro is 10 raised to the power minus 6. The prefix milli is 10 raised to the power minus 3. So here we have a unit for mass and a unit for volume. Sorry, I forgot to write cube. A unit for volume, kg and meter cube, gram and meter cube. So option D is correct. Question number 15. The total energy input E in a process is partly transferred to useful energy output U and partly transferred to energy that is wasted W. What is the efficiency of the process? Now the formula for calculating efficiency is the useful energy output upon total input multiplied by 100%. Now this means that in the denominator we should have En. Okay, so A has that, B has that, so C can be the answer. We have to choose from A, B and D. And then we have partly transferred to useful energy output U and partly transferred to energy that is wasted W. Now W is the energy that is wasted, so we don't need it. We only need useful energy output for efficiency. This means that in the numerator we must have U and in the denominator we must have En. Okay, so U over En, this is the correct answer. W over En, this won't be the answer. U plus W, no. A is the correct answer. 15. The answer is A. Question number 16. An escalator is 60 meter long and lifts passengers through a vertical height of 30 meter as shown. To drive the escalator against the forces of friction when there are no passengers requires a power of 2 kilowatt. The escalator is used by passengers of average mass 60 kg and the power to overcome friction remains constant. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meter per second? Now see, first thing we have to do is calculate the weight of these passengers, the collective weight, total weight. Now the formula to calculate weight is mass multiplied by G. The average mass is 60 kg and there are 20 passengers, so 60 multiplied by 20 and the value of G is 9.81. Okay, so this is the weight and 60 multiplied by 20 multiplied by 9.81 is 11772 Newton. Now this weight is a force. 11772 Newton is a force. The formula to calculate work done is force multiplied by distance in the direction of force. Now what the escalator is doing is that it is doing work against gravity. It is moving passengers against gravity. They're being raised vertically to a height 30 meter above the ground. So 30 meter is the distance moved in the direction of force because it's the vertical distance and G acts vertically downwards, okay, towards the center of Earth. So the distance is 30 and the force is 11772 Newton. So the work done is 11772 Newton multiplied by the distance 30 meter. Okay, so we multiplied by 30. The answer we get is 353160 and the SI unit for work done, which is joule. Now this is work done. Now what is power? We have to find out power. The power is the rate of work done or energy converted. So power is work done upon time. We have work done but we don't have time. We have to find out time. We are told that the escalator is traveling at 0.75 meter per second. 0.75 meter per second. Okay, so it covers 0.75 meter in a second and it travels 60 meter. Okay, so 60 meter is the distance it travels and in 1 second it travels 0.75. So how much seconds does it take to cover this entire 60 meter? So 60 divided by 0.75 is equal to 80 meter. 80 seconds. So 80 seconds is the total time the escalator takes for these covering these 60 meters. So now we have time, which is 80. We also have work done, which is 353160. We have to calculate power. So power is work done, which is 353160 over time, which is 80 seconds. So 353160 divided by 80 is equal to 4414.5 and that's a unit for power, which is watt. Okay, now this is the power the accelerator puts into use to move the passengers above. But the escalator also requires a power of 2 kilowatt when there are no passengers to drive the escalator against the forces of friction. So 2 kilowatt means 2000 watts. So we have to add these 2000 watts in these 4414.5 watt. So 2000 watt plus 4414.5 watt is equal to 6414.5 watt. And 6414.5 watt is equal to 6.4 kilowatt. This means that option B is the answer. Okay. B is not the answer, C is not the answer, D is not the answer. Option B is the correct answer. Question number 17. A rock of mass 40 kg is released from rest from a height of 20 meter above the surface of a planet. The rock has a kinetic energy of 32 kilojoule when it hits the surface of the planet. The planet does not have an atmosphere. What is the weight of the rock on the surface of the planet? Now, since the planet does not have an atmosphere, this means that there are no resistive forces acting, and there is no air resistance. There is a vacuum, and they're telling us that the rock is released from a height of 20 meter, and when it reaches the bottom, the kinetic energy is 32,000 joules. At the top there is gravitational potential energy, GPE, and at the bottom there is kinetic energy, and this GP is entirely converted to kinetic energy. Since there is no atmosphere, there are no resistive forces. Okay, this means that 32,000 is equal to the gravitational potential energy. Now the formula for gravitational potential energy at Earth is mgh. In this planet, the formula is the same, except that the g does not have a value of 9.81. G has another value, so we'll write m multiplied by g multiplied by h, but g does not have the value 9.81, so we'll solve for g, and we'll write that 32,000 is equal to mass, which is 20 kg, mass, which is 40 kg, multiplied by g multiplied by height, which is 20 meter. Okay, so 32,000 divided by 40 divided by 20, g comes out to 40, and the mass is 40 kg. Weight is m times g. M mass is 40, g is 42, so 40 multiplied by 40 is 1600 Newton. So C is the correct answer. Let's move to question number 18. A metal wire is stretched. The wire obeys Hooke's law, which quantity has a value that does not change. The extension changes, the strain changes, the stress changes. There is only one quantity that is unique for every material, which is the Young modulus. It does not change. 18D. The answer is D. Question number 19. An object is stretched until it reaches the elastic limit. Which statement must describe the stress on the object when it is at the elastic limit? Option A. It is the maximum stress for which the object obeys Hooke's law. Now, elastic limit is the limit beyond which, if force is applied, the object does not return to its original length. Okay. And Hooke's law is that force must directly be proportional to the extension or length. So A is not the answer, because this option is related to the limit of proportionality. Option B. It is the maximum stress that can be applied to the object before it has elastic deformation. No, B is not the answer, because if you draw a graph, a force extension graph, so if you see, if this is the elastic limit, the point which I have marked E, so the area before E, that region is the region with elastic deformation, and the region after it is the region with plastic deformation. So elastic deformation takes place up till the elastic limit, and afterwards there is plastic deformation. So B is not the answer. C. It is the maximum stress that can be applied to the object before it has plastic deformation. Yes, C fits. C is the answer. D. It is the maximum stress the object can withstand before it breaks. No, D is not the answer. It is the breaking point, which is after which the object breaks if you apply more force. So D is not the correct option. The answer is C. Question number 20. Which statement about progressive waves is correct? They are always transverse waves. No, it's not necessary. They can exist in solids but not liquids. No. They decrease in frequency as their speed increases. No. They transfer energy away from their source. Yes, that's the correct choice, because progressive waves transfer energy away from their source, whereas in stationary waves, energy is confined within loops. Okay. Let's move to the next question. Question number 21. A cathode ray oscilloscope CRO is used to determine the frequency of a sound wave. The diagram shows the waveform on the screen. The time-based setting is 5 milliseconds per division. What is the best estimate of the frequency of the sound wave? Now, the formula for calculating the frequency is 1 over time period t, and the time period t is the time taken to produce one complete wave, and frequency f is the time taken is the number of waves produced in 1 second. Now, if we use this as the point and we find out the number of waves, so this is one wave, then this is another wave, and this is half a wave. So we have 2.5 waves till this point, and these 2.5 waves take how many seconds? Let's count the number of boxes, number of divisions. 1, 2, 3, 4, 5, 6, 7. 7 divisions. One division is 5, represents 5 milliseconds. So 5 multiplied by 7 is 35 milliseconds. Okay. And 1 millisecond is 10 raised to the power minus 3 seconds. So the time is this 35 multiplied by 10 raised to the power minus 3 seconds for 2.5 waves. Okay. This is the time taken for 2.5 waves. Now if you divide 35 multiplied by 10 raised to the power minus 3 by 2.5, you will find out the time taken to produce one complete wave. Let's do this. The answer is 0.014 seconds. This is the time taken to produce one complete wave. Okay, and the formula we have is 1 over t. So let's divide 1 by 0.014. The answer we get is 71.42 Hertz. 71.42 Hertz. And B is the answer. Okay. Let's move to question number 22. In question number 22, the warning signal on an ambulance has a frequency of 600 Hz. The speed of sound is 330 meters per second. The ambulance is traveling with a constant velocity of 25 meters per second towards an observer. The ambulance passes and then moves away from the observer with no change in velocity. Which overall changes in observed frequency takes place between the times at which the ambulance is a long way behind the observer and when it is at a long way in front of the observer? Now this question is about Doppler effect. There is a formula for a Doppler effect about the observed frequency, which I am writing as FO, and the formula is the the speed of sound, which is 330 meters per second, multiplied by the frequency of the warning signal of the ambulance, which is 600 Hertz, frequency of source, upon the speed of sound, which is 330 again, plus minus the velocity of the moving thing, which in this case is ambulance. So the velocity of ambulance, which I am writing, let's say Vs. Okay, so this is the formula. Now minus applies to an approaching source. Now in the initial position, this minus sign applies, and plus applies to a receding source. So plus applies to the final position. Now we have to use this formula to calculate the observed frequency initially and the observed frequency finally. So let's begin. We have 330 multiplied by 600 over 330 minus 25. Initially, this is the initial case. So the answer we get is 649 Hertz. 649 Hertz. This is the initial observed frequency, and let's find out the final frequency. Observed frequency 330 multiplied by 600 over 330 plus 25. So 330 multiplied by 600 divided by 355, 557 Hertz. 557 Hertz. And if you subtract 557 from 649, the answer you get is around 92 Hertz, and C is the closest one, so C is the answer. Let's move to question number 23. Brief pulses of red, blue and green light are emitted from the sun at the same time. The pulses travel the same distance to reach Mars. Assume that the pulses travel in a vacuum for the full duration of their journey. In which order would these pulses of light arrive at Mars? So the answer is obviously A, because all these colors are part of the visible spectrum, and all these are electromagnetic waves, and all electromagnetic waves have a speed of 3 multiplied by 10 raised to the power 8 meters per second in vacuum. So A is the answer. Question number 24. Two coherent progressive waves from different sources meet at a point. Which condition must be satisfied for there to be zero resultant amplitude at the point where the two waves meet? The two waves must be emitted from their sources with the same intensity. No, this is not a condition. They must have the same amplitude. If there are two coherent waves, they must have the same amplitude, and there is a condition that there must be zero resultant amplitude at the point. This means that there must be destructive interference, and for destructive interference to occur, we must have same amplitude. So that's the only condition. A is incorrect. B, the two waves must be in phase with each other at the point. No, they cannot be in phase. They must be out of phase for destructive interference to occur. The two waves must be traveling in opposite directions. No, that is a condition for stationary waves, not for coherent waves. The two waves must have the same amplitude at the point. Yes, they have the same amplitude, because see, the amplitude is the displacement from the rest position. Now you might be wondering that for destructive interference to occur, the thing is that one wave must have a positive displacement and one must have negative displacement. The amplitude of both these waves must be equal. Okay, so that's the case in answer number in question number option D. Okay, so let's move to the next question. Question number 25. A corridor is 13.2 meter long and has closed doors that reflect sound at both ends. The speed of sound in the air in the corridor is 330 meters per second. What is the lowest frequency of sound that could create a stationary wave in the corridor with a node halfway along it? At closed ends, we have nodes, and at open ends, we have antinodes. Since there are closed ends at closed doors on both ends, we have nodes. Okay. Now, the lowest frequency means, what is frequency? Frequency is the number of complete waves produced per second. So, lowest frequency means least number of waves. This is the case where there is the least number of waves, nodes in these three positions, antinodes in the middle, and this is the case where there is the lowest frequency. Okay, and this is a stationary wave. Now we have to find out that lowest frequency, and the formula is V is equal to F lambda. Speed is equal to frequency multiplied by wavelength. The wavelength, since this is one wavelength, this length, this means that wavelength is 13.2 meter. So 330 is equal to frequency multiplied by 13.2 meter, and 330 divided by 13.2 is 25 hertz. So the frequency is 25 hertz. C is the correct answer. Let's move to question number 26. Water waves of wavelength lambda are formed in a ripple tank. The waves are diffracted as they pass through a narrow gap of width d. D is greater than lambda. Which gap width and which wavelength will cause the largest decrease in the amount of diffraction? Now, for the most amount of diffraction to take place, the greatest amount of diffraction to take place, the wavelength and the gap width must almost be equal. So the wavelength must be equal to the gap length for the greatest amount of diffraction. Gap width. Okay. But they are asking us which gap width and which wavelength will cause the largest decrease in the amount of diffraction. This means that the difference between these two must be the greatest for the largest decrease in the amount of diffraction. The difference must be the greatest. Okay, so and there we are also told that d is greater than lambda. The the width d is greater than lambda, which means that 2 times d will be if we multiply 2 by d, the gap width will be greater than wavelength. Okay, so a can be the answer and d can be the answer, because in both of them we are multiplying 2 with both wavelength and gap width, and these are not the correct ones, since we have to find the option with the largest decrease in the amount of diffraction. Let's check option B and C. In option B, they are multiplying the gap width by 1 upon 2 and wavelength by 2. Now this is obviously incorrect, because we are told that d is greater than lambda. The narrow gap is greater than d. Now if the gap is greater than d, they are dividing it by 2, which will make it closer to the wavelength instead of increasing the difference. So B is not the answer. Let's check C. In C, they are multiplying gap width by 2, which is already greater than lambda. D is already greater than lambda, and they are further multiplying it with 2, and then they are halving the wavelength by 2. They are dividing it by 2, which increases the distance. So they are doing this. Okay, so the difference between these two is increased, which will cause the largest decrease in the amount of diffraction. So C is the correct answer. Question number 27. Two loudspeakers X and Y emit sound waves that are in phase and of wavelength 0.75 meter. An observer O is able to stand anywhere on a straight line that passes through X and Y as shown. The observer stands at a point where the sound waves from X and Y meet in phase. What could be the distances OY and XY? Now, if two waves are in phase, this means that the phase difference between them must be 0 degree, 360 degree, etc. or the path difference must be a whole number of wavelengths. So it can be 0 lambda, 1 lambda, 2 lambda, 3 lambda, where lambda is wavelength. So this is the condition when 2 or more waves meet at a point, and if they are to be in phase, then this is a condition. The path difference between the two waves must be a whole number of wavelengths. Now we are told that an observer O stands anywhere along this dotted line, and there are two loudspeakers X and Y. We are given the distances OY and XY, and we have to find which option is correct. Now there will only be one option in which the distances are given such that the two waves meet at a point where they are in phase. Okay, now for two waves to meet at a point where they are in phase, the path difference between the points must be a whole number of wavelengths. Let's check the options. In option A, the distance OY is 1.25 meter and the distance XY is 3.5 meter. Okay, so this means that O is somewhere here, 1.25 meter, and the distance XY is 3.5. Okay, so this means that the distance OY is 1.25 meter, the distance XY is 3.5 meter. So the distance OX is 3.5 minus 1.25. The distance OX is 2.25 meter. Now the wavelength is 0.75 meter. To calculate the path difference in terms of wavelength, we divide 2.25 by 0.75 and we get the answer 3 wavelengths, and then we divide 1.25 by 1.25 by 0.75. We get the answer 1.667 wavelengths. Okay, so if you subtract 1.667 from 3 wavelengths, you will get the answer 1.333 lambda, which is not a whole number of wavelengths. So A can't be the answer, as the path difference is not a whole number of wavelengths. Let's check option B. In option B, the distance OY is 2 meter and the distance XY is 2.75 meter. Okay, so this means O is somewhere here. The distance OY is 2 meter and the distance XY is 2.75 meter. So the distance OX is 2.75 minus 2, which is 0.75 meter. This is 0.75 meter, and let's find out the path difference. 0.75 divided by 0.75 is 1 wavelength. 2 divided by 0.75 is 2.667 wavelengths. Now if you subtract 1 from 2.667, you will get the answer 1.667 wavelengths. Now obviously B can't be the answer because the answer must be a whole number of wavelength. The path difference is not a whole number of wavelength. Let's check option C. In option C, distance OY is 2.75 and the distance XY is 2. So O will be somewhere around here. The distance XY is 2 meter. The distance OY is 2.75 meters. So the distance OX is again 0.75 meter. Now 0.75 divided by 0.75 is 1 wavelength, and 2.75 divided by 0.75 is 3.667 wavelength. And if we subtract 1 from 3.667, we get 2.667 wavelength as the path difference, and C is not the correct option. Now we have only D remaining, so obviously D is the answer, but let's prove it mathematically. In D, OY is 3.25 meter and XY is 1.5. Okay, so it's almost double. So let's make O this point, and the distance OY is 3.25, the distance XY is 1.5. XY is 1.5 meter, and so OX is 3.25 minus 1.5, which is 1.75 meter. Okay, now if you divide 1.75 by 0.75, you get 2.333 as the answer. 2.333 wavelengths, and the distance OY is 3.25. So if you divide 3.25 by 0.75, you get 4.333 as the answer. Now for the path difference is 4.333 lambda minus 2.333 lambda. Now the path difference is 2 lambda. Since the path difference is a whole number of wavelength, D is the correct answer. D is the correct option. Moving on to question number 28. Light of a single wavelength is incident normally on a diffraction grating. The resulting diffraction pattern is displayed on a screen. Which change makes the first orders of intensity maxima further apart from each other on the screen? Now this question is about diffraction grating. The equation relevant to this question is d sine theta is equal to n lambda. Now they're asking us that which change makes the first order of intensity maxima further apart. For the intensity maxima to be further apart, the angle theta must be greater. The angle must be greater. And for the angle to be greater, the value of sine theta must be greater. Okay. Now let's make sine theta the subject. Sine theta is equal to n lambda over d. Okay. For the value of sine theta to be greater, either n must be greater. N is the order of maximum. Lambda is the wavelength. Either n must be greater, or lambda must be greater, or d must be smaller. D is the distance between adjacent slits, or the grating spacing. Okay. Now let's check the options. Placing the screen closer to the diffraction grating. No, it can't be the right answer because there is no mention of the screen distance in this formula. B. Using a diffraction grating with less separation between adjacent slits. Yes, B seems to be the correct answer, but let's check other options as well. Because if the diffraction grating has less separation between adjacent slits, this means that D is small. So if D is small, sine theta will be greater, and consequently theta will be greater, and the first orders of intensity maximum will be further apart. Let's check C. Using a diffraction grating with more slits but keeping the same separation between adjacent slits. Now, having more slits will not make a difference, but keeping the same separation between adjacent slits, it will, but since there is same separation, then it won't make a difference. Changing the separation would make a difference. Using light with a shorter wavelength. No, we don't need a shorter wavelength. Instead, we need a longer wavelength. Because if there is a shorter wavelength, the angle will become smaller. So, D is not the answer, C is not the option, B is the correct option. Moving on to question number 29. For a current carrying wire, the current can be calculated using the equation shown. What is the meaning of N? Okay. Now, N is the number density of charged carriers. Now, obviously, since it is the number density, and density is related to mass and volume generally, so obviously, the number density N has to do something with volume. So, D is the correct answer, the number of charge carriers per unit volume of the wire. Let's check other options. A, the number of charge carriers in the wire, no. B, the number of charge carriers multiplied by the volume of the wire, no. C, the number of charge carriers per unit length of the wire, no. Only D is the correct answer, the number of charge carriers per unit volume of the wire. Question number 30. The number of free electrons passing a point in a wire in 24 hours is 6 multiplied by 10 raised to the power 23. What is the average current in the wire? Now the formula for current is I is equal to Q over T, where I is the current in ampere, Q is the charge in coulombs, and T is the time in seconds. Now we are given the number of electrons. Each electron has a charge of minus E. E is the elementary charge. The value of E is 1.6 multiplied by 10 raised to the power minus 19 coulombs. Now each electron has this charge. We have 6 multiplied by 10 raised to the power 23 electrons. So what is the total charge? The total charge is this value 1.6 into 10 power minus raised to the power minus 19 multiplied by 6 multiplied by 10 raised to the power 23. Okay. So the answer we get is 96,000 coulombs. Okay, now 96,000 coulombs in 24 hours. But T is the time in seconds. So 24 hours multiplied by 60 minutes in each hour and 60 seconds in each minute. So the answer will be 1.11 ampere. And so option B is correct. Okay. Moving on to question number 31. In the circuit shown, lamp P is rated 250 volt 50 watt and lamp Q is rated 250 volt 200 watt. The two lamps are connected in series to a 250 volt power supply. Assume that the resistance of each lamp remains constant. Which statement most accurately describes what happens when the switch is closed? Okay, now since this is a series circuit, the current across P, there is only one conducting path. Okay, and this means that the current across lamp P is the current through lamp P is also the same as the current through lamp Q. The currents in both the lamps are equal, and the resistance of each lamp remains constant. Okay, so the current I is the same in both lamps. There is a formula, P is equal to V square over R. We are given the power, we are given the potential difference across them. We can use it to find R. Okay, so R is equal to V square over P. Let's solve for R. Okay, so for lamp Q, 250 square divided by 50 watt. So the resistance is 1250 ohm in lamp P, and for lamp Q, 250 square divided by 200. So the resistance is 312.5 ohm. Now we are told that the resistance remains constant and the current is the same in both lamps. because they are in series, and there is a formula for the power dissipated, which is P is equal to I square R. Now, for a moment, ignore I, since they are the same in both. I current is the same in both lamps, and eventually you'll get rid of it when you divide them. So let's only take R in consideration. The resistance in P is 1250. The resistance in of lamp Q is 312.5 ohm. If you divide them, you get 4 as the answer, which means the resistance of lamp P is 4 times the resistance of lamp Q. And we ignored I, but if you include I in this, you are actually comparing the power P. So this means that the lamp P emits 4 times as much power as lamp Q. And this is what option A suggests. So option A is the correct answer, and A is the answer for question 31. Moving on to question 32. A piece of wire has a length of 0.8 meter and a diameter of 5 multiplied by 10 raised to the power minus 4 meter. The IV characteristic of the wire is shown. What is the resistivity of the metal from which the wire is made? Now the formula for resistance is R is equal to rho multiplied by L over A. Okay, now L is the length in meter, A is the area in meter square, and this rho is the resistivity in ohms per meter. Okay, now we have to calculate this rho. So let's make rho the subject, resistivity the subject. So we have resistivity is equal to resistance multiplied by area divided by length. Now we are given the length, the diameter, which we will use to find the area, and we have to find the resistance. So the formula for resistance is V over I. Now you can use this formula. You can use the values from this graph to find the resistance. Okay, you can either use the formula 1 over gradient, since gradient is y values upon x values, and they have made current the y-axis and potential difference the x-axis. Or you can simply divide 10 by 5, or you can use any other values. So we are dividing 10 by 5, and the resistance is 2 ohms. Okay, so we'll use the resistance as 2 ohms. Rho is equal to 2 multiplied by area. Now we have to find out the area. Okay, so the diameter is 5 multiplied by 10 raised to the power minus 4 meters. So the area is pi radius square. Okay, so the radius is diameter divided by 2 squared. This is the resistance, this is the area, and then we have to divide their product by the length. The length is 0.8 meter, so we divide this by 0.8. Okay, now in the numerator we have 2 multiplied by pi multiplied by 5 multiplied by 10 raised to the power minus 4 upon 2 squared. So 5 multiplied by 10 raised to the power minus 4 divided by 2 is 2.5 multiplied by 10 raised to the power minus 4. This is the radius. If we square it and then we multiply it by pi and then by 2, we get 3.9269 multiplied by 10 raised to the power minus 7 as the answer, and then we have pointed in the denominator. So the final answer we get is 4.9 multiplied by 10 raised to the power minus 7 ohm meter. Okay, so C is the answer. In question number 33, 10 cells each of electromotive force EMF 15 volt are connected together as shown. What is the combined EMF between the terminals X and Y? Okay, now all the 10 cells are connected. We'll not multiply 1.5 by 10. We have to check if these are connected in the correct order, which means if they follow one order, negative, positive, negative, positive. Okay, so let's check. Here this is positive, negative, positive, positive, negative. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 cells are connected in the same order, but then in the 10th cell they have negative and positive in separate directions, so the current will flow in opposite directions. So it's actually 9 cells multiplied by 1.5 minus 1 cell multiplied by 1.5, since this cell is in the opposite directions compared to the other cells. So 9 multiplied by 1.5 minus 1.5 is equal to 12 volt, and option C is the correct answer. Question number 34. A cell of electromotive force EMF E and internal resistance R is connected to a variable resistor as shown. The resistance of the variable resistor is gradually increased from R to 3R. Which graph shows the variation of the potential difference PD across the internal resistance with the potential difference PD across the variable resistor? Now, this is similar to a potential divider circuit. In a potential divider circuit, there is a formula. The formula is that the potential difference, let's suppose V. Okay, so the potential difference V across a resistor is equal to the resistance of that resistor upon divided by or upon the combined resistance of the two resistors. Okay, so this is the formula, and then we multiply it with the input voltage, which in this case is E. So this is the formula for the potential difference or voltage across any resistor. Okay, so what happens is that if you increase, according to this formula, if you increase the resistance of a variable resistor, which they are increasing from R to 3R, the potential difference across that resistor, which is this, will obviously increase. So first, if it was V, it will increase. If it was E, slightly less than E, so it will obviously increase to a greater value. Now let's check the options. Okay, now the value of V will increase, obviously, because the resistance of that resistor is increasing. So let's check choices we have. Okay, now option B can't be the answer because in it the value of V is decreasing, and same is the case with option C. In both of these, the value of V, capital V, is increasing, the potential difference across the variable resistor. And now we have option A and D. We have to check option A and D. Now it is obvious that when the potential difference across a resistor will increase, a variable resistor capital V will increase, the potential difference for the other resistance will obviously decrease, because in a series circuit the total EMF must be equal to the potential differences across the components or the resistors. So it can happen that the potential difference of a variable resistor is increasing, and the same is happening with the other one. So D can't be the answer, because in it the potential difference of both the components, this one and the variable resistor, is increasing. Only A can be the answer, because if the potential difference is increasing of capital V, which is the variable resistor, the potential difference of the internal resistor must decrease. So A is the correct answer. Question number 35. Each of Kirchhoff's two laws presumes that some quantity is conserved. Which row states Kirchhoff's first law and names the quantity that is conserved? Okay, now Kirchhoff's first law is related to current, and Kirchhoff's second law is related to potential difference and EMF. Okay, now the first law is the question is about the first law, so it has to be about current. So option C and D are incorrect because they are about EMF. option A and B are related to current. But Kirchhoff's first law, the quantity that is conserved is charge. So option A is correct and B is incorrect. Moving on to question number 36. A cell has electromotive force, EMF of 8 volt and negligible internal resistance. The cell forms part of a circuit as shown. The reading V1 is 4 volt and the reading V2 is also 4 volt. What is the resistance of resistor R? Okay. Now, if you see that there are two resistors, 4 ohm in a parallel circuit. The effective resistance of resistors in a parallel circuit, the formula is 1 upon R is equal to 1 upon R1 plus 1 upon R2. So the effective resistance which we'll have is, if the combined resistance is 1 upon R, we'll have 1 upon 4 plus 1 upon 4, and the value of R will be 2 ohm. Okay, so this means that the combined resistance of this circled part is 2 ohm. Okay, now for a moment forget that there are two resistors of each of 4 ohm in this circled part. Suppose them to be one single resistor of 2 ohm. Okay, now in a potential divider circuit, there are two resistors and potential difference is shared between them. Voltage is shared between them. Okay. Now, if the resistance of both the resistors are equal, then the potential difference between them is also equal. Same is the case with this. The reading V1 is 4 volt and the reading V2 is also 4 volt, which means that the potential difference across them is equal. If the potential difference is equal, the resistance must also be equal, since they are similar to a potential divider circuit, which means that this R must be equal to 2 ohm. Okay, now if this R is equal to 2 ohm, so B is our answer. Okay, the rest are incorrect. B is our answer. Question number 37. In the circuit shown, the cells have negligible internal resistance and the reading on the galvanometer is 0. What is the value of resistor R? Okay, now see, for a moment ignore this circled part and only look at the above circuit where 4 volt is the main EMF source. We have two resistors 9 ohm and 3 ohm in series, and obviously this is a potential divider circuit similar to a potential divider circuit. Now this 4 volt is shared between these two resistors. Now let's find out how they are shared. Okay, so the potential difference across the 9 ohm resistor is 9 over 9 plus 3, which is 12, multiplied by 4. So 9 over 12 multiplied by 4 is 3 volt, which means the potential difference across the 9 ohm resistor is 3 volt, and the potential difference across the 3 ohm resistor is 4 minus 3, so this is 1 volt. Okay, now 3 volt and 1 volt. The second thing is that there is a galvanometer and the reading on the galvanometer is 0. Now, obviously the reading on the galvanometer is 0 when the potential differences of a resistor, when the potential difference across a resistor and the other thing is the same. That there is no difference between them. Okay, this means that the potential difference across this 6 ohm resistor is equal to 3 volt. Okay, so can we use this to find the value of R? Yes, we can use this because we can use the potential divider formula. Now we know that the potential difference across the 3 volt resistor is equal to, across the 6 ohm resistor is equal to 3 volt. Okay, we also know that the resistor we are talking about is of 6 ohm and the total resistance is 6 plus R, and the EMF is 9 volt. Okay, so this is the equation and we'll solve for R. So 6 multiplied by 9 is 54. 54 is equal to 3 multiplied by 6 plus r. If you divide 54 by 3, you get 18. 18 is equal to 6 plus r, and r is equal to 12 ohm. So C is the correct answer. Question number 38. When alpha particles are directed at gold leaf, almost all alpha particles pass through without deflection. A few alpha particles are deviated through large angles. What are the reasons for these effects? Now, the reason for point number 1 is that the volume of a nucleus is very small compared to the volume of the atom, and most of the atom is empty space. The reason for point number 2 is that the most of the mass of the atom is concentrated in a tiny space called the nucleus. Okay, now let's check the options. Most alpha particles have enough energy to pass right through the gold leaf. No, this doesn't make sense. Option B. Most alpha particles miss all gold atoms. No. Option C. The gold nucleus is very small, so most alpha particles miss all nuclei. Yes, the nucleus is very small. And point number 2 is that occasionally the path of an alpha particle is close to a nucleus. C makes sense. It seems to be correct. Let's check option D as well. The positive charge in an atom is not concentrated enough to deflect an alpha particle. No. And 2 is occasionally an alpha particle experiences many small deflections. No. So C is correct. Question number 39. A nucleus X is radioactive and decays into a nucleus Y. X and Y are isotopes of the same element. Which combination of particles could have been emitted during the decay process? Okay. Now, in alpha decay, what happens is that the nucleon number, 2 neutrons and 2 protons are lost. 2 neutrons and 2 protons are lost. So what happens is that the nucleon number decreases by 4 and the proton number decreases by 2. In beta minus decay, what happens is that the proton number increases by 1. Okay. So which combination of particles could have been emitted during the decay process? Now, a nucleus X decays into a nucleus Y. So this means that the proton number must be the same, because in isotopes, the difference is their atomic mass or the nucleon number. The nucleon number, the number of nucleons is different, the number of neutrons is different, but the number of protons remains the same. The important thing is that the number of protons must be the same. So nucleus X and nucleus Y must have the same number of protons. Okay. So in option A, 1 alpha particle and 1 beta particle. No. In alpha decay, 2 protons will be lost, and in 1 beta negative decay, what happens is that 1 proton there will be an increase of 1 proton and 2 protons will be lost. So there will be a difference of -1. A is not the answer. 1 alpha particle and 2 beta particles. B can be the answer, because in alpha decay, when an alpha particle is lost, 2 protons are lost, and in beta minus decay, there is an increase of 1 proton, and since there are 2 beta minus particles, so there is an increase of 2 protons, so the net difference is 0. B can be the answer. Let's check other options. 2 alpha particles and 1 beta particle. No, there will be a difference of 4 protons will be lost and only 1 will be gained, so there will be a difference of 3. In option D, 2 alpha particles and 2 beta particles. So 2 alpha particles means 4 protons and 2 beta particles means 2 protons. So there will be a difference of 2. Only option B is the correct one. Question number 40. A positively charged meson consists of a quark and an antiquark. What could be the quark and antiquark? Okay, so a positively charged meson. Now, a positively charged meson means that the combination of a quark and an antiquark must be such that the charge is positive. Okay, so now what could be the quark and antiquark? Charm and anti-up. Now, the charge of charm is +2/3 and the charge of anti-up is -2/3. So the net charge is 0. It can't be the answer. B. Down and anti-top. The charge of anti-top is -2/3. The charge of down is -1/3. By the way, this is 2/3, 2/3, 2/3, -1/3. So the net charge is -E. The charge for strange and anti-bottom. Okay. Now the charge for anti-bottom is +1/3E and the charge for strange is -1/3. So the net charge is again 0. Up and anti-strange. The charge for up is plus 2 upon 3e, and the charge for anti-strange is plus 1 upon 3e, which means the net charge is plus e. And D is the correct answer because it is the only option where there is a positive charge. This was A-level physics, February-March 2022 past paper. I just solved it. In case you're new, subscribe to my channel and comment on this video about more content which you would like me to make. Thank you.